Hello, I will have some examples on analysis of frames and machines and drawing their free body diagrams. This example is asking us to find, let's see, the forces in C and D. So the power pole in my backyard has an arrangement as shown to support the wire. The weight of the wire is 400 pounds right there. Find the loads on the bolts C and D. If a wood is rotten and can only support a load of 300 pounds at each bolt, should I be concerned? Okay, so let's see. First of all, this looks awful similar to a truss, but it's not a truss. Why is it not? Because of member CA. CA, sure, has forces at C, forces at A, but it has additional forces attached to it at point B, either in tension or compression. Okay, so, and because of that, it is not a two-force member, and because of that, we need to draw a free body diagram of each member. As soon as you find one member that is not a two-force member, then it's not a truss anymore, and you have to take it apart. Okay, so let's see. I have a free body diagram of CA, and then I have another free body diagram of a two-force member right there. Tension, so it's tension. Okay. All right. Point A is a pin, so I'm going to put a CX and a CY. I have a 400 pounds pushing down, and then I have a force aligned with dB that is either compression or tension. I'm going to draw it this way. You're going to see why. Okay, I'm going to explain in a little bit why is that. So that force is tension, so that means this member is in tension, and I'm going to draw it this way, F, B, D, or dB. Okay. Look, point D is a pin. So the way I drew it, basically I put a dx and dy. Okay. So that makes sense. It's a pin, so it has a dx and dy, but you got to pay attention that whatever direction you put, the resultant needs to be always line up with the axis of the member. Okay. This angle is 30. And that's all I need. So before we go too much further, let me do this. FDB cosine 30 and FDB sine 30. Okay. All right, now all of my forces are either in X or either in Y. Let me get rid of this. Okay, so now it's much easier. So if I write summation of moments about point C being 0, let's see, I have F dB sine 30. That needs to be at a distance of this distance right there. And that is how much? 24 cosine 30. Because this angle is 30 also. So 24 cosine 30 inches. And then I have another force of F dB cosine 30 at a distance of, now I'm looking at this distance, 24 sine 30 inches. Okay, now let's figure out the signs. FDB sine 30 is trying to rotate this way, which is my sine. FDB sine 30, FDB cosine 30, same way, so both of them are plus. The only other force that I have is that 400 pounds at a distance of, this is the distance I care about now. That one is 24 plus 24, 48 cosine 30. And that one is trying to rotate this way, so that's negative, equals 0. The only unknown I have is force of F dB, which is 800 pounds. Okay. Which is the force at point D. Because remember, this is now 800 pounds. Now this is 800 pounds. Okay. The other force that we are trying to find is Cx and Cy. So all I have left is summation of forces in x direction being 0. F dB is now 800. So Cx, so Cx minus 800 cosine 30 equals 0. So Cx is 693 pounds. Summation of forces in y equals 0. And that means minus 400 plus 800 sine 30 plus Cy equals 0. Cy is 0 pounds. Okay, so those are the forces, force at C and force at Y. So force at C, if I just want to find one force for it, let me go next to slide. If I want to find force at C is, remember, it's like that. So it's 0, 693 pounds, and it's going to be 693 pounds. So force at C, 600 pounds. Force at D, 800 pounds. The problem said, hey, my bolts can carry only 300 pounds. So what do you think is happening? Yes, this one is more than 300 pounds. This one is more than 300 pounds. So it's rotten at both of them. So both of them are going to fail and cause a failure. Okay, let's look at another one. Table AB supports box weighing 10 pounds applied at point G. So it's like we have a 10 pounds here. I remember force is a sliding vector, so I can put it right on the table. Find the vertical force that operator must apply. Okay. I'm assuming that the operator needs to push down based on what I'm seeing. Let's call it P. To keep the table in equilibrium in position shown. Find forces supported by all members. Okay. So this is a machine because this is a 2 force. This is not a 2 force. This is a 3 force. And this is a 3 force. Or even multi-force. More than 2. Anything more than 2, we don't care. So now I have to draw a free body diagram of each member. FBD of each member. Let's see. Member A, B, G. Outline of the shape. It's good enough for me. I have 10 pounds applied at it at point G, and then I have point A, which is attached to a 2 force member. 2 force member is either in tension or compression. I just like to call it FA. Once this one is in tension, the other one is opposite of it, which is also in tension, going away from the pin. Okay. Point B, same way. But look, point B is not attached to a 2 force member. So I have a little bit of better freedom to put the forces on there. So I'm going to put a BX, or let's put it the other way. Oh. BX and a by. The other b needs to have opposite, so it's gonna have bx and a by. Oh, opposite is the other way, so sorry. It's gonna go down, by. Point C is a pin, so I'm gonna put a cx and cy. Point P, I already put it there. It's a vertical force of coming down. All right, so this is my free body diagram. So let's see. The goal is to find forces in all members, meaning bx, by, fa, cx, cy, bx, by, and force P. So we have tons of unknowns. So let's see. So this one, I have two unknowns, but they're equal, so I can't do much about it. Let's just start with this free body diagram. I have three unknowns. So let's see. Let's take moment about point B and find FA right away. Okay, I'm gonna go a little bit quicker through the equations now. I have 10 pounds at a distance of 4 inches to point B. That is plus I have FA sine 30 at a distance of 12 inches up to point B equals 0. Remember, this one has a vertical component and a horizontal component. The horizontal component, which is FA cosine, it goes through point B, so I don't need to worry about it. I only take FA at this distance of 12 inches between point A and point B. So this gives me FA of minus 6.67. That means it was actually in compression. So this one is minus 6.67 pounds, minus 6.67 pounds, minus 6.67 pounds. All right. And then, since we're at this free body diagram, let's write sigma fx equals 0, sigma fy equals 0. And from these two, you should be able to get bx of 5.774 pounds and by of 6.67 pounds. Okay. So I got these three figured out. Bx, I have it. By, I have it. So let me draw another free body diagram here a little bit clear. So now I have Bx that I found to be 5.774. I have a By that I found to be 6.67 pounds. I have a Cx and a Cy, and I have a force P. Okay. So let's see. Summation, let's write summation of forces about point C equals 0. I have force P at the distance of the problem has given this distance 10 inches. Rotating this way, so that's plus. By at a distance of 12 inches. The problem has given us this distance as well, 12 inches. And that one is trying to rotate the beam this way, so that's minus. Bx at a distance of, we have to find this distance. Okay, let me see. So this angle is given 30. This length is given to be 12 inches. And this is what I'm looking for. Okay, so the distance between Bx and point C that I'm looking for is going to be, let me see, tangent 30 will be the distance that I'm looking for over 12 inches. Okay, so it's going to be 12 tangent 30 inches. That's what I'm looking for. Okay, Bx is also trying to rotate this way, that's minus. And do I have anything else? No, it's about point C, so Cx and Cy are 0. By, I have it 6.67. Bx, I have it 5.7. And this will give me P of 12 pounds. Okay. Rest is easy. Summation of forces in x being 0, so Cx plus Bx, which is 5.774 pounds, is 0. So Cx is minus 774 pounds. I'm not following the 3 significant rules here, but you know, if this is your final answer, you need to present it as a significant figure. So minus P minus Cy minus By equals 0. P, I just found it to be 12. By, I just found it to be 6.67. Therefore, Cy is 18.67 pounds. Okay. Let's look at another one. Stairs leading to a balcony are shown for the 400 pounds and 600 pound forces. If F is 200 pounds and P is 0, this P is 0, so I don't even need it. Find reactions at point D, okay, which is just the dy, and force supported by bar BE. Okay, so force this one, FBE, either compression or tension, because that's a 2-force member, and dy. Those are the forces they need. Okay. Let me draw free body diagram. So this is, look at member CD. The force is at the end of it, but also there's a force F in the middle of it. Not exactly in the middle, but you know what I mean. So that makes it a multi-force or a 3-force. Same here. It's a 3-force or even more. Nope, that's not a 3-force. That's multi-force. Multi-force. So as soon as you see one multi-force, that's a frame or machine. In this case, it's a frame. So I have to take it apart. Let's see. Free body diagram. This is member DC. I have another one right there, and I have a 2-force member right there. Okay. Let's just start with the easy one, which is a 2-force member, because the forces are either in tension or compression. So force BE, force BE. They're the same, equal, opposite. I have a force E, or sorry, pin E here, force BE. I have a pin B here, force BE. Okay, so see that two-force member started helping us a lot. Then let me do the top member. I have a 400 pounds there. I see a pin at A, AX, AY. I see another pin at C, CX. Let's just draw them the other way. Okay, now I move on to my next point C. These are the common points, same pin, so I have to draw opposite forces on them. Moving on, I have a force of 200 pounds, force F, that's given in the problem. And lastly, oh, I have another 600. I did not even see that. So 600 pounds. And lastly, I have a roller, which is a dy. This is a really busy free body diagram, lots of unknowns. And let's see. Okay. dy. All right. So dy is easy to find. You know why? Because if I take the entire frame, and let's see, outline of it, which is good enough for me as this, the entire frame. I'm not taking it apart. Let's see, I have a 400 pounds on it. I have a 200 pounds on it. I have a 600 pounds on it. I have a dy because it's a roller, and then I have an AX and AY. Okay, I have 3 unknowns, so I can solve this. And here's how we can solve it. The easiest way is writing summation of moment about A being 0. Okay, so it's dy at this distance, 200 at this distance, 600 at this distance, 400 at this distance. So very straightforward, will give you dy of 595.2 pounds. Okay, so one of the reaction at point D, one of them is already done. 595.2 pounds. Okay. What else I need to do before moving on? So let's see. Let's use this free body diagram next. I'm going to redraw it here quick. So I have it. I have CX, CY, 200, 600, FBE, and I have 595.2 pounds. All right, so let's see. This FBE, do we have the slope triangle for it? It is 56, 68. Easier to go with the angle alpha. So tangent alpha is going to be 56/68. So I'll get alpha of 39.47. So 39.5. All right. I think I have everything that I need, because the problem is asking us to find this force. That's the goal. So if I'm smart about it, and write one moment about point C being 0, the only unknown I have is FBE. And so let's see. FBE, this will be FBE cosine 39.47. This is going to be FBE sine 39.47. Okay. So if I want to write moment about point C, I get dy, which is 595.2 pounds at a distance of, I think if you add all of those together, you're going to get 108 inches. And then you get 600 at a distance of 54 inches. You get a 200 at a distance of 38 inches. Both of these are trying to rotate this way, which is a plus, 59 on the other hand is going opposite, so minus, plus, plus. And these two forces now. I have FBE sine 39.47. The distance between the vertical distance that horizontal distance that I'm looking for is 38 inches. 38 inches. The other distance is already given on the figure, 56. So this distance is given by 56 inches. So I have FBE cosine 39.47, 56 inches. If I figure out the signs, I am done with this equation. The first one is trying to rotate the beam this way, the vertical component, and that makes it a negative. The other one, the horizontal component, is trying to rotate with my sign, so that's plus equals 0. The only unknown here is force of BE, and if you do the math, you're going to get 1273 pounds as for the force. the last example that I have for you, a frame used for a chair. So it made our life much easier. Tells us it's already a frame. Frame used for chair is shown. Find the force supported by members ABC, ABCD, ECFG, and BF. Basically every member that I see in that frame. Okay. So let's see. Now that I know it's a frame, let's draw the free body diagram. And at this point, I hope everyone is an expert in drawing the free body diagram. So I have to take it apart. So this is going to be my ABCD member. This is going to be my ECFG member. And don't forget that little 2-force member in between. All right, let's see. ABCD has a 40 one side, has an AY on one side, it's just a smooth contact, has a BF going one way, BF, BF, BF. Okay. Point C is a pin. The first one really doesn't matter which way you draw it, but the second one, that needs to be opposite direction. And the only thing that I see is 60 pounds. There you go. Oh, I missed point G, so GY over there. So you can take any of the free body diagrams you want. I'm going to take this one. Taking that one, I have too many unknowns, 4 unknowns. So why don't we take the entire frame first. Okay, entire frame and outline of it. So somehow I need to draw outline of it. There we go. It's good enough. It has AY, has GY, has 60 pounds, has 40 pounds. Looks very straightforward. Let's write moments about A. Okay, this should give you GY. This is G, by the way. GY of 40 pounds. And then just use a simple summation of forces in Y0 and you get AY of 60 pounds. Alright, so AY is 60 pounds. Now, if I look at the member, this free body diagram, the star free body diagram, let's see, summation of forces about point C is 0. I have a BF multiplied by 5 inches perpendicular distance between C and line of action, 5 inches. Then I get 60, which is AY, multiplied by perpendicular distance between those two is 4 inches, given on the figure. The direction of it is going this way, so that one is negative. And then the last one that I have is 40, and the distance between that one is given also 4 inches, equals 0. That one is trying to rotate against my sign also, so that's also negative. So from here I get BF, or force of BF. Remember, that doesn't mean member, that means force of BF is going to be 80 pounds. Okay, now it's easy enough again. Summation of forces in X direction, it's going to give us CX of minus 80 pounds. Summation of forces in Y being 0, it will give us CY of minus 20 pounds. So the direction of C that I drew was, in reality, both were opposite direction.